12.4, Similarity in Right Triangles, Geometry. The essential question, how do the altitude to the hypotenuse of a right triangle help you to use similar right triangles to solve problems? The answer, the altitude to the hypotenuse of a right triangle into two smaller triangles that are similar to each other and to the original triangle. You can use the geometric means theorem to find missing measurements using indirect measurement. So basically what I just read is that, let's say you have a right triangle, like a nice big one, okay? And all of a sudden you find an altitude and you cut this guy in half. Well, not in half, but basically you cut at a 90-degree angle and it forms two more triangles, okay? Basically they're all similar to each other. Okay, and basically you can start using indirect measurements to find a missing piece. Okay, so you're going to see that with your problems and your examples. Definitions: the geometric mean of two positive numbers is the positive square root of their product. What does that mean? Well, here's an example. So find the geometric mean, and we're going to identify it as x, of the numbers given, 4 and 25. So you're going to set it up, x equals the square root of 4 times 25, because your definition of a geometric mean literally just says it's two positive numbers inside a square root that are multiplying. Okay, and that's what we have right there. So you need to go back to your algebra and be like, all right, square roots of numbers again, okay? Remember you used to have like a square root of, let's say, square root of 36. And back in the day you were like, oh, that's plus or minus 6. Well, when we're talking about the geometric mean in algebra or in geometry, it's kind of talking about length or distance or height. And basically what the definition says is it can't be a negative, because in geometry there's no such thing as negative distance. Okay, so that's what they're talking about. So 4 times 25 is 100. The square root of 100 is 10. Notice how I'm not doing the plus or minus like we did in algebra. That's because you can't have a mean that's a negative. Okay, like a basketball player, his average, it can't be a negative number for his shots, okay? So his three-pointers, like I think Shaquille O'Neal had a terrible average for three-pointers, but at least it wasn't negative, and that's kind of a joke. You can't have negative means. So therefore your geometric mean of 4 and 25 is 10. Just know that in physics, if you had a pendulum, and you had 4 over here and 25 over here, basically you would put the pendulum, or the scale, sorry, that would be balanced at 10. So if you put it at 10, they'll shift and the scale will be completely level. It's very hard to do. Some of you try to balance your ruler on your finger before. You got to make sure you're at the mean or the average, which is basically your midpoint. Okay, moving on. Geometric means theorem. Basically, the theorem is that the lengths of an altitude, the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. So here they say h squared, okay, so equals x times y, or, and this is the one that I used last slide. Okay, if you go back to the last slide, I did x equals the square root of 4 times 25. Or yeah, that was it. So that's what I used right there for the last slide. Okay, this guy. All right, so basically, visually what's happening is in this situation, if you wanted to find this guy right here, the length of h, you would have to do basically what we did with the geometric mean on the last slide. Okay, so to find him, you would have to basically set it up x times y. And x is here, and y is here. Now, the other theorem, or part of it, is that the length of a leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to that leg. What does it mean? What does it mean? Okay. What it means is that to find A, okay, you basically have to square root x with c. So c is really just x plus y, okay, the whole thing, okay. And to find b, so let me clean it up a bit so you can see like some kind of visual pattern here. So let's use this. This is better. Blue guy with blue guy, blue guy with blue guy, with this blue guy, and then green guy is going to be the square root of x and c, okay? And then purple guy is going to be this, to solve this guy, square root of y and c. So you can see how, like, if it was a video or a game, like a board game, how things get divided up. So take your time with that one. It's pretty intense. So let's look at application, because the math of it's pretty, pretty intense. So let's go ahead and just see applications, because I know you guys are like, okay, what do I need to know for a test or my homework or HRW? So let's focus on application. So find the indicated value, and that's going to be x at first, and then we're going to solve for y. So let's focus at x. Okay, so that's the altitude. So I know that I need to find my geometric mean between my two bases, 10 and 2. So I'll find my geometric mean of 2 and 10. So there's my geometric mean. X equals square root of 2 times 10. Okay, that's the definition of geometric mean in application form. 2 times 10 is 20. And the square root of 20 is, well, 2 times the absolute value of 5, or no, square root of 5. Now, if you can't recall, think about your past, and you should remember that, well, square root of 20, let's see, that's 4 times 5, or 2 times 10. It depends on who you are. Okay. And then this 2 pairs up with this 2. He gets out of jail. This guy gets lost in prison. So this 2, he gets out of jail. This 5, he can't rat out on anybody. So he stays in jail. Okay, that's how it works. That's just a little recall from algebra days. Okay, to find y. All right, so we're setting up a proportion, and you really don't need to if you remember your last slide. Okay, what goes with what? If you remember last slide, you should be thinking like this. You should be thinking like this. My y is going to be proportional to this guy plus this whole thing. So you're going to have 10 and 12, because 10 plus the 12. Okay? And that's where we get this 12 from. So if you set up the proportionality, just remember 10 is to y as 12 is to y, because we're talking about two different triangles on the same triangle. It's crazy, all right? So we can go ahead and cross multiply. I think if I was to multiply to get y all by himself, I would have to multiply by a 12y. And I know you're like, Mr. Webb, why? Because if you do that, you're going to multiply. Let me see if I already typed it in. Okay, so, right, so we went ahead and multiplied by y. So 12y times 10 is 120y. That's how I got this guy right here. Okay, and then I left the y down there. They'll cancel out eventually with the y's. And then 12y times y is 12y squared. Okay, and the 12's will eventually cancel out and just become 1. So, as you can see, the y's canceled out on the left-hand side. Got 120. And then just equals y squared. And here's the joke, okay? Your book sets it up as proportionality, and it's very healthy to know that, especially for your test. But a kid might be like, well, you did this over here. Why can't I just do that the same way? Okay, so you have to know the proportionality so you can use the right numbers. And if you do that right, you know that y equals the square root of 10 times 12. So if you know your theorems, you can just go straight to the geometric mean and get the same answer down here. You don't even have to deal with all this jazz with the proportional statements. And that's if you just know your theorem from your last slide. So, by the way, the square root of 120 is 2 times the square root of 30. Example 2, find x. Okay, so first things first, you have to see it this way. You have x, and x is going to be the geometric mean of 5 and 7. So go ahead, find the geometric mean. Okay, so if you know the proportionality statement, you could do that, and this is how the book does it. If you want to be efficient and independent, you can go ahead and just start doing something like this, because you know how to set it up already, because you know your theorem. Okay. And that would just be the square root of 35. Choice is yours, but if you're weak at proportional statements, you should practice, because they'll probably have a question on your test. So as you go through, basically what happened from one line to the next is I was just like, you know what, I'm going to multiply by a 7x, because if I do that, those 7's will become a 1, and you're just going to have x squared, which is what we got here. 7x will cancel out with the x down here, and this will become a 35 right there. So that's why I went ahead and multiplied by a 7x. And then eventually you're just going to take the square root, and look at that. You get the same answer as if you already knew how to set it up. Okay, so if you know your theorem, you'll be over here, because you can see it, you understand it, and it's simple math. You don't have to deal with proportionality statements. All right, one key idea about similarity statements, and this is pretty important for the first 3 problems of your homework. You have 3 triangles in this one picture, okay? It's pretty dense. So let's take a look. We have 3 different triangles. So we have triangle, the big triangle, okay, we have PQR, and that should be similar to our other triangle, PRS, and that should be similar to PQS. So you have 3 triangles inside that one image, all sharing one side or another, and they're all similar because of that. It's like friends, you know? You guys are usually all similar to each other in some respect, especially sense of humor or morality. And that's because you all belong to the same group, okay, of humans, I guess. Humans work the same way. If they're not very similar, they don't fit, and there goes the expression. You don't really fit in. It's kind of like that. Okay, so make sure you're, hanging out with people who are similar. Okay, well, that's not really, it's not really correct. Diversity is always nice. All right, here we go. So your homework, page 671 through 672, numbers 1 through 21. I know it's a large amount, but 12.4 is usually the weaker end of Module 12. So I want to make sure you have enough practice for this. That way we can get better equipped for your test. Of course, we'll have HRW as well. So good luck. Bye.